Welcome to Everyday Mathematics. Here at Everyday Mathematics, as we always say, we do enjoy solving the harder problems, but above all, we also see and appreciate the beauty in the simpler problems. So today's problem comes from MIT 2024 Integration B Finals, tiebreaker number 1, which is the indefinite integral of 1 over the fourth root of x to the power 4 plus 1. This is a very beautiful problem. Before I jump into the solution, I'd like to thank our subscribers. Thank you so much. Thank you so much for the support. It's because of your support that we come here time and again to share with you some of the very beautiful solutions that we come up with. For our first-time visitors, what we do here at Everyday Mathematics is we go around and about and look at harder problems. We come back here and share with you what we think are solutions that are befitting to these problems. For our repeating visitors who haven't gotten the opportunity to subscribe to our channel, would just like to encourage you, please do consider subscribing to our channel. So the first thing I would do with this problem, for me, when I do see a plus and x to the power something, a quick substitution that I think about is tangent substitution. And so I say let x squared be equal to tan theta, such that 2x dx d theta equals to sec squared theta, and therefore dx equals to sec squared theta over 2x d theta. And so since x is the square root of tangent theta, so we have dx be equal to sec squared theta over 2 root square root of tan theta d theta. And so 1 over the fourth root of x to the power 4 plus 1 dx is equals to this integral of 1 over fourth root of tan squared theta plus 1 over sec squared over 2 square root of tan theta, which now, since tan squared theta is the same as sec squared theta, we have now half this 2 pulled out of the square root of 1 over fourth root of sec squared theta times the sec squared theta over square root of tan theta. Fourth root of sec squared theta is the same as the square root of sec theta. So going forward, we have half of the integral of 1 over square root of sec theta times sec squared theta over square root of tan theta. And so tan theta can be expressed as sine theta over cosine theta, which means that it's the same as the square root of sine theta times the square root of sec theta. So therefore, since we have 2 square root sec theta square root sec theta square root is the same as sec theta. So we are left in the numerator with sec theta. So what we have here is half of the integral of 1 over sec theta times sec squared theta over square root of sine theta. So this divided by this results into half times the integral of sec theta over square root of sine theta. So sec theta is the same as 1 over cosine theta. So we have here the integral of 1 over cosine theta square root of sine theta. Now we want to eliminate the square root sign. We say let u be equal to sine theta. Therefore, du d theta is the same as cosine theta. We apologize for this mistake. And so du is the same as cosine theta d theta, and du over cosine theta is the same as d theta. And what that means is du over square root of 1 sine squared theta is equal to d theta. And sine squared theta is the same as u squared. So du over square root of 1 minus u squared is the same as d theta. So this integral here becomes 1 over 2 integral of 1 over square root of 1 minus sine squared theta in place of cosine theta, and then we have sine theta here, and we forgot to include d theta here. Okay. So this means that in place of cosine theta, we have 1 minus sine squared theta, which is 1 minus u squared. In place of sine theta, we have u. In place of d theta, we have du over square root 1 minus u squared. So these times this results into 1 minus u squared, and we're left with square root of u there. And so let y be equal to square root of u. Therefore, y squared is the same as u. 2y du is equals to 1, and therefore 2y dy is equals to du. So this integral here now becomes half the integral of 1 over 1 minus y to the power 4 in place of y squared, and then y in place of root of u, and then in place of du we have 2y dy. And so this y and this cancel, and okay, this one and this will cancel out. And so we're left with the integral of 1 over y to the power 4, which is an easy integral because now we can use integration by, not integration by parts, but we can use partial fractions. So we can split this in form of 1 minus y squared, the denominator, in form of 1 minus y squared and y plus y squared. So expressing that into partial fractions, we have half the integral of 1 over 1 minus y squared plus 1 over 1 plus y squared. And so we can split this first integral further, and the 1 over 1 minus y squared is the same as half of 1 minus y plus 1 over 1 plus y, and then that half times the half that was already there, this becomes a quarter, the integral of 1 over 1 minus y plus 1 over 1 plus y. And then this next integral remains half the integral of 1 over 1 plus y squared. So quick thing, this is the same as a negative a quarter, natural logarithm of 1 minus y, the integral of 1 over 1 minus y. And then this is the same as a quarter, natural logarithm of 1 plus y. And then this is a very famous integral, which is now half times the arctangent of y. Now, since y is equal to square root of u, we just plug in the square root of u there. We can swap this positive and negative, and so we have 1 over natural logarithm of 1 plus square root of u minus 1 over 1 over 4 times natural logarithm of 1 minus square root of u plus half arctangent of square root of u. So that is that, and also since u is equal to sine theta, we can plug sine theta in place of u, and that's what we get. But again, since x squared is equal to tangent of theta, that means that if we have a right angle triangle like that, and then we have the base angle be theta, then tangent of that theta is the opposite over the adjacent, which is now x squared, and that being opposite and then adjacent is 1, and the hypotenuse is x squared plus 1 squared, which is just 1. Therefore, sine theta being opposite over the hypotenuse is sine theta is x squared over the square root of x squared plus 1. So therefore, our final integral of 1 over the 4th root of x squared, x to the power 4 plus 1 is equal to a quarter natural logarithm of 1 plus, in place of sine theta, we have square root of x squared over the square root of x squared plus 1. And in place of the sine theta, we've done the same. In place of the sine theta, we've done the same. So the next thing is we can express this as a common base, and therefore square root becomes root the power 4. And so here we have 4th root of x squared plus 1 plus x minus a quarter. This is also 4th root. We apologize for that mistake. And so we have a quarter natural logarithm of 4th root of x squared plus 1 plus x over 4th root of x squared plus 1 minus a quarter of 4th root, a natural logarithm of 4th root of x squared plus 1 minus x over 4th root of x squared plus 1 plus arctangent of x over the 4th root of x squared plus 1. This is, we apologize for that mistake. And so the final answer is the same as 4th root natural logarithm, quarter times natural logarithm of the 4th root of x squared plus 1 plus x over the 4th root of x squared plus 1 minus x plus half arctangent of x over the 4th root of x squared plus 1. So this is our final answer. In the Final answer provided, they swapped. So you could also express it as half arctangent x over 4th root of x squared plus 1 plus a quarter natural logarithm of 4th root of x squared plus 1 plus x over the 4th root of x squared plus 1 minus x. Same answer. But this was the answer that was provided. We apologize for the errors there, but all the same, you get to understand how this problem could have been solved. We thank you so much for your support. If you've not subscribed, we encourage you to please consider subscribing to our channel. Your support does a lot. It does motivate us to keep coming here time and again. That was really an absolute fun hanging out with you. So thank you until next time. Tutaluha la prochaine fois.